Okay, so hello everyone. My name is Bart Kuijper, and a little bit about myself here. Let's quickly go through. So the power of demystifying your stack. Today I'd like to take you on a journey where I share my experience in pulling some covers from a technology. And it could be that you listen to this and find that you are interested in a specific technology that I talk about its inner workings or hidden workings. But it could also be that you want to gain some value from the process of demystification. What is to demystify? Why would you want to do it? And importantly, which aspects you want to delve into when demystifying, and which ones you kind of pragmatically want to pass by. Because at heart, I am a pragmatic developer. I like modern abstractions, but I'm also curious, and sometimes technology just bears too much magic for me. So that's why I like to sometimes uncover some of its secret. Not all of it, because we also have, of course, jobs to do. So I guess the real question is, what is the power of demystifying your stack? So this is the BehaviorSubject, an NPM package as part of RxJS. It comes standard with Angular, but it is usable across any JavaScript project. I will be using it as a main starting point to discuss state management. And of course, I could have picked any other state management solution. And perhaps the BehaviorSubject is not a state management solution as much as these. Others that are more opinionated and that offer best-in-class practices on its usage. Everyone familiar with aspects like reducer functions, selectors, actions, effects, etc. would probably agree. But the BehaviorSubject does offer the ability to manage state, and in a rather easy way. Thus, it serves as my starting point today. But what it really boils down to is that using APIs like these, contracts, if you will, can sometimes feel a bit like magic. I don't know about your brain, but for me, I sometimes learn how to use it, but it's almost as if it requires a subset of my brain as a storage. I can't relate it to any vanilla JavaScript knowledge I have. And this is probably the main argument why I believe that demystification, when done cautiously, is really helpful. Because after understanding the underlying magic, you can store it alongside grounded coding knowledge. And with caution, I mean that, of course, you can always dive deeper and deeper, which in my eyes should be avoided, as pragmatism is ultimately what keeps us happy programmers. So, the BehaviorSubject. So let's look at a stream of data emitted from events in an asynchronous fashion. It might sound abstract, but the button, the simple button that adds a number, is actually doing that. It's asynchronous. It can produce a stream of data, and the BehaviorSubject could be there to carry that stream through the project by using its next method, which we will see later a bit. And of course, in all its simplicity, the button serves as a visual example of asynchronicity. As I click, data stream flows as data comes in little chunks over time as a stream. And I don't mean a stream as you would think of a river, like continuous, but more of a conveyor belt in a factory, because I could wait hours before clicking. So it's more a conveyor belt and not a stream that is constant. What you see happening here with the BehaviorSubject from RxJS is a push-based architecture. And there's something about that BehaviorSubject that enables that pushing of updates into the DOM. And don't be mistaken, it's these very same principles that are used in arguably much more exciting ways when thinking about real-time web, chat messages, or anything you could come up with. But for this demonstration, I think a simple summing of numbers will suffice. So what if we don't have magic? What if we have a simple variable that just holds states, just like the behavior subject from RxJS did, at an initial of 0? Just like the other example, we plus the amount on each click. But unlike the other example, we see absolutely nothing because this is not a push-based architecture. If we want any updates, we need to be deliberate by, for example, adding some kind of fetch, and then it would come in. By looking at these differences, we can widen the question of what methods and properties are missing to make it work similarly to the behavior subject. Well, we know that the behavior subject has some kind of next method because we can call it to update its internal state. But this hardly changes anything, as it only deals with updating the value and not pushing it through a system. But the behavior subject has more to it. In order for updates to actually show, we need to subscribe. By doing so, every time a value enters the behavior subject through the front door, by using the next method, it immediately comes out the other way through the callback, and then it can be assigned to the DOM in this fashion. But please note that if you, of course, use Angular, we can also use what is called the async pipe for subscribing automatically, which, of course, is an abstraction in itself worth uncovering. But basically, it subscribes automatically without the need to explicitly do so. But all these techniques we see today can also be used in React and any other framework, or just vanilla JavaScript for that matter. Okay, so we have a push-based functional enabler on the one hand with the behavior subject, and we have an undone fetch primitive on the other hand. What else do we need to add to our code to give some superpowers, just like the RxJS behavior subject has? Well, two things are essential. One, a method that allows us to subscribe. And two, a way to store that new subscription in a collection of sorts, for example, an array. So a method that allows us to subscribe and a collection that stores that subscription in memory. So why do we need to store these subscribers in a collection? And do remember that the behavior subject does exactly these things underwater. The only difference is that we just don't see it. Okay, so why do we need that list of subscribers? Well, in a way, this is similar to, let's say, a telephone list with people interested in some kind of service. We need to call each one of these subscribers once we have something to say, once we have an update. So in our case, once we click that plus button and a number gets added, we call a function on each subscriber. Each subscriber needs to have that function or method. And we could call that something like signal, which then effectively releases the latest state. So what we end up with is an object that holds state that can deal with updates to that state. So that every time state changes, the whole list is iterated over to give the next update. And this is a pattern, and we call this pattern the observer pattern. And I'm going to read a part and then explain. So the observer pattern is a software design pattern in which an object, named the subject, maintains this list of its dependents called observers, and it notifies or signals them automatically of any state changes, usually by calling one of their methods. So let's break that down. So we have that list, that collection, which first is empty, but as subscriptions comes in, it fills up. We take that list and perform some kind of side effect on each item of the list. Namely, we call a signal method that each subscriber needs to have, and it passes the latest state. Now let's get to the second part. So it says it's mainly used for implementing distributed events handling systems in event-driven software. Well, in other words, our asynchronous event emitting example in the form of a button. And then it goes on to say, in those systems, the subject is usually named a stream of events or stream source of events. So in our case, that's the corresponding stream of data, are the numbers that follow on each click. Great. So let's take a look at this observer pattern in action. So just as in the example that we saw in the presentation, we have a button and a number that increases on each click. So we created a class that we use instantly in the component just for ease. For this example, I use Angular, but it could be made identically within React, Vanilla.js, or any other framework. The framework just simply determines the syntax of how the component renders the DOM. But since that is not the main aim of the presentation, I advise you to look past that and roughly translate it to the context that you're most familiar with. Also, please note that Angular by default uses TypeScript. If you are not familiar with TypeScript, just ignore everything indicated in light green, followed by the double dots. So we start by initializing a state, just how we would in a behavior subject or any other Redux-like methods. What is different here is that we initialize this empty collection in the form of an array. So we made a contract by using TypeScript that it only lists observers or subscribers, if you will, that implement the signal method, the method that ultimately pushes the state to the subscribers. In order for the interested subscribers in any component through the application to enter that list, we have to add this subscribe method, which takes care of adding subscribers into the list. And then we have a simple method to add and notify, which performs two actions. Mainly, it does the summing that we've seen by changing the state. And secondly, it calls the update method, which in turn is responsible for going over each of the observers that are now present and calling on them the signal method. And finally, we do a little bit of cleanup that clears any subscriber from the list. And this we do on the onDestroy lifecycle method in the actual component, which can be seen here. So on init, we subscribe with our signal object. And on the click, we do the add and notify. And that closes the loop. So back to the slides. Good. So now that we looked at the basic implementation of the observer pattern, we know that it holds a list of subscribers. We know that it starts off empty and that the component subscribes with an object that implements that signal method. This is a little bit like the landline between the state class and the component receiving. And this can, of course, be multiple components. We also know that the initial state and any changes forward are pushed to all subscribers in the list through the for each. And that our event stream that followed here is handled through the same loop communicated, thus effectively creating a real-time push-based mechanism. Another way to look at it, in the top here, we have a handler which holds subscribers. It iterates over them. It notifies them of the initial change and any change forward, and grants them the ability to subscribe. And of course, the unsubscribe. And the subscribers are a little bit like ears. They listen for changes and carry the state further to, in our case, a number that is being streamed. Remember that the behavior subject was easy. You provide updates through a next method, subscribe to whatever comes out the other end. No need to hold a list of subscribers or to iterate over them, updating each time. And therefore, there's absolutely no reason in a modern application to resort to the observant pattern in its raw form. Because first and foremost, it might be slow. There might be memory leaks if you don't unsubscribe properly, which I, by the way, don't do. In example 1, I just clear the whole list. And in example 2, I don't unsubscribe at all. Because in order to do what you know, you need to know about it. You can't know what you don't know. And therefore, it's good to stand on the shoulders of giants. So yes, RxJS might be a little bit opinionated with the behavior subject, but it has its benefits. And of course, it comes with other functions like piping as well. In terms of memory leaks, as mentioned, Angular has the async pipe, which doesn't only subscribe, it also automatically unsubscribes. And we can actually do something similar in React by using the useEffect hook with a cleanup. And you can put that in a custom hook as well. But as I mentioned, opinionated is a good thing because it covers your tracks in many ways. So my advice is do this once. Do it as a way to understand the magic, or at least some of it. And after that, never consider using it in production. Because I truly think that our brains have two ways to store information. Think of how you used to learn country capitals in high school. Did you learn them by heart, or did you dive into the country, uncover some aspects about it, and all of a sudden that capital name is not just a bunch of words, but it bears meaning? Yes, it requires a bit more time, but you will never forget it, and it gives a more pleasant feeling in my experience. So for the last part of my presentation, I want to circle back to state management, because ultimately what we've seen so far is definitely state, but it's not management. As a state management concept comes with ideas like actions, payloads, effects, the amazing dev tools from Redux, possibly typed if you're into that, reducer functions, the complex state, and selectors. And these state managers like Redux or NGRX come with their own version of these ideas, very similar. But let's take a look at how much we can implement ourselves. So we go back to the app. So here we have an office management app. We can add offices. And we can see how many employees we have in total up here. And this is, of course, in a different component to demonstrate the ability to derive state from one singleton state manager. And we can also delete offices and have the employee count respond to that. So this time around, the component and the service are disconnected, not like in the previous example. That is normal for a more professional app. The store is injected right here. If you're not used to dependency injection, see it as a way for a component to make use of the properties and methods of a class. It's an Angular thing. So now that we have access to the store, we can call its methods, like subscribe, which we do here, and which of course implements that callback of signal that we've seen before. But this is exactly how it was in the previous example. So let's look at some differences now that we have a more complex state. What you can see is here that state comes in terms of offices as it is selected, for example, which could of course also be number of employees or yeah. So let's go into the reducer by going into here. So here we have the reducer. This is the reducer function, but first let's look at the initial state that we give right here. And of course, we have, again, that line that carries all the observer. Again, something specific to the observer pattern and something we would absolutely not have to do if we used a package of some kind. So then the reducer, it goes through actions, fully typed, and when landing on a job, it updates the state accordingly. And that state is communicated to each subscriber right here, so that they have the latest state ready. Lastly, we also extend the window object and provide the Redux DevTools with actions and state. So let's take a final look at how that looks like. So if we go to state, see it here, we can remove some state, for example. Back to the slides. So in conclusion, I think that implementing the observer pattern by hand and thinking critically about state management instead of just sheepishly going through the motions adds a lot of benefits. It assures that you stay awake while going through the boilerplate of setting up. You might even take some turns and twists along the way to use simpler implementations. For example, by relying heavily on RxJS instead of fully fledged Redux or NGRX in Angular. But I don't see any value in using the raw pattern in production, as performance issues could arise. So in other words, do it once as a way to grow a pair of new eyes. But know when you have reached the information you like, that there is always another abstraction for you to uncover. Thank you.
Thank you, Bart. It seems that at the moment there's no questions. I'm going to give it about a minute to see if any questions come in.
Sure.
Otherwise, we'll go to a break. We're going to break until 7:45 because that's what's also on the planning, and people might join in at the time. So as I said, I'm just going to give it a minute. Nothing's coming in so far. Otherwise, I suggest I'm going to put the setup for the break, and I'll keep an eye on the comments in the meantime. So I'm just going to put it on hold. Thank you so much for your talk.
Like a plan. Great.
Okay.